Hello everyone, my name is Devanand. I am faculty of Heat Transfer in ACE Engineering Academy, Hyderabad. So I welcome all to this score booster series conducted by ACE Online or ACE Academy. Now, as you know, this program is specially for TS GENCO-AE exam. Okay, so make sure this coursework, whatever I am going to teach, it is nothing to do with the GATE or engineering services or some other public sectors. This course is specially designed for TS GENCO-AE exam. In that, today I am going to talk about heat transfer. Now it's a very interesting or surprising thing for me because I am a faculty of mechanical department. I had an experience in mechanical department heat transfer subject. But as you know, in the TS GENCO exam, recently in the last notification, you observe there is a change in the syllabus and there are some subjects which are from mechanical engineering added, like thermodynamics, power plant and heat transfer. So as a faculty of heat transfer, it's my responsibility to guide you properly, and that guidance only for this TS GENCO exam, so that you can get the more and more score, right? So this session is not for the awareness of the heat transfer or exam, because we had a lot of videos on this, what is exam, how to prepare and all that. So I am not going to discuss any syllabus or important topics or like that, nothing. I am going to here conduct the session for the score boosters. So the today's session, whatever the time you are like spending to watch my videos, so definitely I am sure that I will make it worth it, so that I am going to solve the various numericals that will be pattern of TS GENCO. Okay, so please listen carefully. Listen carefully. We started this series. So every day 6 p.m. there is a live streaming. Make sure it is a live. Okay, and the schedule is already there. Like on 23. There is a heat transfer, then 26 thermodynamics and so on. So this is the signal, this is the sequence you need to follow. So please listen, you need to available at 6 p.m. every day if you want to enjoy the live sessions. Okay, so what is the motto of this? The motto of this videos are like a quick revision, practice over the questions. That is the motto. The motto is not to teach you the everything. The motto is to just make you aware about the examination. Okay, now so as a heat transfer, now please listen carefully. This is my subject, heat transfer. Now as a heat transfer faculty, I can say that whatever the syllabus there in the mechanical, the same syllabus is there in electrical engineer also. So the syllabus is same. Is it mean that question also same? No. See, the in mechanical engineering, the heat transfer is considered to be fundamental subjects where the questions are in depth. But as an electrical engineer, they will not expect from you that much fundamental knowledge from the heat transfer. So examiner is expecting from you that you should know what is conduction, what is convection, what is radiation and some basic equations. So please listen, whatever the 12th standard physics is there, in the 12th standard whatever the heat transfer is there, like conduction meaning, convection meaning, radiation meaning, that if you revise very well, like most of the questions you can tackle. Okay, now so let's start without wasting time. Let's start the question series. So the first question from radiation chapter. What is the basic equation of thermal radiation from which all other equations of radiation can be derived? Means the question is like that, what is the basic equation in radiation so that all the equations can be derived? So please listen, the option A is said to be Stefan-Boltzmann equation, which is very popular. Like everyone knows if it is radiation means Stefan-Boltzmann equation. But what is the question? Question is, what is the basic equation of thermal radiation which all the other equations of the radiation can be derived? That is a question. So please listen, there is one very fundamental equation, that is Planck's equation. Okay, This Planck's equation said monochromatic emissive power of black body, this is the equation, e raised to power 5 C2 lambda T minus 1. So this is your basic equation. What is this equation? This equation is Planck's equation. Okay. Planck's is the name of scientist, Max Planck's, right? So listen, Max Planck's EB lambda C1 upon lambda raised to power 4 e raised to power C2 lambda T minus 1. This is the equation. So please listen, suppose if you integrate this one, if you integrate this equation, entire equation if you integrate, then you will get Stefan Boltzmann. Stefan Boltzmann. Okay. If you derive this d by d lambda, EB lambda equate to 0. Suppose if you equate to 0, then you will get Wien's displacement law. Okay, so there is a Wien's displacement law. Displacement law. So then you will get Wien's displacement law. Now if you change the C1 and C2 value, let us say C1 is far less than C2 or C2 is far greater than C1, like that, there are other boundary conditions. If you change, you will get the different equations. So what I want to say that Planck's equation is such an equation where all the other equations can be derived. All the other equations can be derived. So that's what you need to go for Planck's equation. Okay. So you need to go for Planck's equation. Make sure that you should not go for Stefan Boltzmann. No. So we need to find a basic equations where other equations can be derived. So from the Planck's equation, you can derive the other equations. Okay. This is the question. This is the question. Next. So the question is, let us say this is satellite. This is satellite in a space. So what is the question? A satellite floats in a deep space with a high velocity. It will continuously lose heat by. Please listen, this is the satellite kept in a space. So here there is no medium. So it is a vacuum. If it is a vacuum, means there is no conduction. Conduction cannot be possible because conduction required medium. Then there is no possibility of convection. No possibility of convection because conduction, convection both required medium. Then there is only one possibility. So this satellite is losing heat via electromagnetic wave, means that is only possibility of radiation. So there is no conduction, no convection. So there is only radiation possibility is there. So continuously lose heat by convection? No, there is no convection. Conduction and convection? No, because both required medium. Radiation? Yes. Radiation, convection? No. So only the answer is C. That one is radiation. Okay. Next, see, these are the questions from this is question from radiation. Now move to the next one. Listen, if a body is at 2000 Kelvin, the wavelength at which body emits maximum amount of radiation. So please listen, there is a body. If you take this body temperature is 2000 Kelvin. What is the wavelength so that it radiate max? Okay, what is the wavelength so that it radiate max? So please listen, for this we need to use Wien's displacement law. Wien's displacement law. So you can use Wien's displacement law. What is that law? Lambda into T is equal to 2898 micrometer. Micrometer is a unit of wavelength into Kelvin. Okay, what is the temperature? Now you can write lambda is equal to 2898 by T. 2898 by T. So here what you can write, 2898 by 2000. Okay, so if you solve this, you will get 1 point something. So unit should be micrometer. So this is 1.45 micrometer you will get if you solve this. So if you solve this, you will get 1.45 micrometer. So what is this lambda? This lambda is a peak wavelength. Peak wavelength. This lambda is peak wavelength, means lambda is peak wavelength. At lambda body emits maximum. Body emits maximum. Lambda is equal to peak wavelength. At lambda body emits maximum, right? So what I am trying to say, this is wind displacement law. Try to remember this. This is wind displacement law. Lambda T is equal to 2898. Remember one thing, whenever the examiner asks at what wavelength the body emits maximum. So if you are interested to know at what wavelength body emits maximum, then you have only this equation. Lambda T is equal to 2898. Remember this. So lambda is that lambda where body emits maximum at that particular temperature. So it has a constant 2898 micrometer Kelvin. Okay, this is the question. Next. This is very interesting question. Okay, so the question is, ice is very close to. So the option A is a grey body, option B is a black body, option C is a white body, option D is a specular body. So what I am trying to say, please listen carefully. You are electrical engineer. You are not you don't have any coursework of heat transfer in your undergraduate, right? So this is completely new for you. So grey body, black body, white body, specular body, these are not a color of the body. Please listen carefully. Black body doesn't mean that the body should be black, or white body doesn't mean that body should be white. So if you see the question, the ice is very close to, most of the student will think it is a white body. No, it is nothing to do with the color. Please listen. If whatever the amount of energy, so right now I am standing here, in front of me there are many lights are there, fans are there, thermocols are there. So everyone is radiating on my face. So exactly the same thing when everything is falling on this body. When the body absorbs completely, that is called black body. So black body is perfect absorber. So listen carefully, black body is a perfect absorber. So whatever the amount of energy falls, everything get absorbed. That is called black. Black is nothing to do with the color. Please listen carefully. Black is nothing to do with color. Of course, it's a very detailed topic. No need to discuss right now. What I am trying to say, as a human point of view, you cannot judge. You cannot say, sir, this black body is a black body or this white is a black body. What is that? There is a huge confusion. Please listen. Human cannot identify whether that is black body or white body. Why? Because whatever the wavelength will fall or emit, human can't see. We can't see. Right now my body is emitting many wavelengths. Can you see? No. So for you it's just a human body. There is no radiation from my body. So this camera or your human eye cannot capture that wavelength. So when we are unable to detect the wavelength, how we can say whether it is black or black or white. See, please listen carefully. There are many sounds are there nearby, but can we listen, can we hear all the sounds? No, there should be a matching with frequency. So similarly, there are many signals are there, but frequency need to be matched. So similarly, in black body what happen, whatever the energy will fall, everything get absorbed. That is called black, and it is nothing to do with the color. Nothing to do with the color. So in the first stroke, what you will see, sir, ice is a white. Ice is white from human point of view. You are seeing like a white. But remember, radiation you can't see. Wavelength you can't see. What type of wavelength it is absorbing. What type of wavelength it is reflecting. You can't see that. That's why human can't judge the black body. So remember, ice is a very good absorber. Ice is good absorber. Ice is very good absorber, therefore ice is close to black body. Okay, so please listen carefully. Ice is close to black body. Clear? So ice is close to black body. Listen, it nothing to do with the color. Nothing to do with the color. So here we can write here black body. Nothing to do with color. Nothing to do with color of object. Okay. So it is nothing to do with the color of object. Hope it is clear. So ice is a good absorber. Whatever the energy will fall, most of the things get absorbed. So go for black body. Please listen, this question is very popular. So ice is very close to. Please listen. You need to check, you need to select black body. Okay. Next one. Next one. If the temperature of the solid surface changes from 27 to 627. Okay. If the temperature of a solid surface changes from 27 to 627, then its emissive power will increase in the ratio of. So please listen carefully. Let us write E is emissive power. E is emissive power. E is emissive power, and that E directly proportional to T raised to power 4. So remember, in the radiation, E is directly proportional to T raised to power 4. Now increase in the ratio of, so let us say T2 by E1 is equal to T2 by T1 raised to power 4. So E2 by E1 is equal to T2 by T1 raised to power 4. So what is T1? 27. 27 plus 273. So that is 300 Kelvin. T2 is what? T2 is 627. So 627 plus 273. So this will be 900 Kelvin. Please make sure in radiation temperature must be in Kelvin. Must be in Kelvin. So here you can write E2 by E1. This will be 900 by 300 raised to power 4. So E2 by E1, this is 3 raised to power 4. So this will be 81. This will be 81. So go for the option D. So remember, this is very, very important. Please listen, this question is very important for your examination. Okay. So first thing you need to understand, radiation must be in Kelvin, and emissive power is directly proportional to T raised to power 4. Directly proportional to T raised to power 4. E2 by E1 is equal to T2 by T1 raised to power 4. So you will get this 81. Okay. So hope it is clear. So 81 you will get. Next question. Consider the following statement. First one, for metal the value of absorptivity is high. So please listen carefully. Metals are good reflectors. Good reflectors. Metals are good reflectors. Reason, in the metals there are free electrons. So whenever the electromagnetic wave come near the free electrons, so that will get reflected. So electromagnetic wave get reflected from the metals. You maybe observe when you go to take a CT scan, X-ray or MRI scan, so that instructor will say remove the ornaments. So ornaments you need to remove. So metallic objects are there. Any metallic objects are there, we should not wear, because from there is a reflection. So metals are good reflectors, means poor absorbers. So of course it is poor absorbers. So first is what? For metal the value of absorptivity is high. No. Reflectivity is high. Absorptivity is low. Absorptivity is low. So metals are low absorber. They will not absorb. They will reflect more because of presence of electron. Second, for non-conductors. Non-conductors, those who don't have electrons. For non-conductors, reflectivity is low. Yes. Yes. Non-metals are good absorbers. Non-metals are good absorber. Are good absorber. So good absorber means poor reflectors. So they are very good absorber, reflectivity is low. So this is correct. For polished surface, reflectivity is very high. Yes, polished surface looks like shining. It's very shiny surface, so they have very good reflectivity. So 3 is correct. Then next, for gases, reflectivity is very low. Yes, gases are good transmitters. Anything will, most of the things will pass from the gases. So reflectivity is very low. So if you go to the option 2, 3, 4, 2, 3, 4, so you need to select option A. 2, 3, 4. So option A is correct. Okay. Option A is correct. Next. Okay. Hot air is flow over a flat plate. Okay. So let us say this is the flat plate. This surface temperature is 150. Hot air at 150 degrees Celsius flow over a flat plate, maintain at 50 degree. Okay. So here what he said? Here, listen. Hot air. So there is a hot air, 150 degrees Celsius, flow over the flat plate, maintain at 50 degree Celsius. Is the force convection heat transfer coefficient. So heat transfer coefficient, that is 75 watt per meter square Kelvin. The heat gain rate by the plate. So from here there is a heat gain Q. So what is that? So use the Newton's law of cooling. Okay, use the Newton's law of cooling. Newton's law of cooling. So what is that? Q is equal to HAS T infinity minus Ts. So higher minus lower. So Q is a heat gain. H how much? 75. Surface area how much? 2. And this how much? This is 150 minus 50. So Q is equal to, this is 150 into 100. 150 into 100. Okay. So this will be 15,000. So this is watt. Okay. But what he said? He said in kilowatt. So divided by 1000. So if you divide it by 1000, you will get 15 kilowatt. So A is a right answer. So here simple, we use the Newton's law of cooling. Newton's law of cooling, capital Q is equal to HA delta T. We use this and we got this 15 kilowatt. 15 kilowatt. Okay. Now hope remember Fourier law of heat conduction, Newton's law of cooling, Stephen-Boltzmann law. This is mandatory, you should know. Newton's law of cooling, Fourier law of heat conduction, Stephen-Boltzmann law. This is mandatory, you should know. Okay. Now we'll move to the next question. The purpose of providing fins on the heat transfer surface area is to increase. So please listen carefully. Let us say this is the hot body. Okay. Now imagine, please listen, this is your hot engine, this is hot engine, okay, and this engine you can see that there is a metal trace, there is a extended surface. So this is called fins. So you can see in the engine there is a metal trace like that strips, that is your fins. So what is the purpose of fins? The purpose of fin is, if you see the Newton's law of cooling, what is Newton's law of cooling? HAS Ts minus T infinity. Q is equal to HAS Ts minus T infinity. The purpose is whatever heat is there, that heat has to dissipate. The heat has to go outside. The purpose of the area is heat should go outside. See, listen carefully. Whenever you are you are eating something, food item which is very hot. So for the rapid cooling, what you will do? You will spread the food. So you will spread the food, right? So if you spread the food, then surface area will increase, and that food, hot food, will be cool faster. So will be cool faster. So always remember the agenda behind the increasing surface area. So why we are adding this extra surfaces? Why we are adding extra? See, this is my body. Suppose if I stretch my hand, so this is my extra surface. So wherever there is a air contact, so air will absorb the heat and body will cool faster. So the purpose of the fin is to cool the body faster. Okay. So what is the option? What is the option? The first one, the temperature gradient so as to enhance the heat transfer by convection? No. There is no temperature gradient. Effective surface area to promote the rate of heat transfer by convection? Yes. B is absolutely correct. So we are increasing the surface area so that the convection will increase. Convection will increase. So you need to go for option B. Option B. There is nothing to do with turbulence or pressure drop. Okay. Next one. Okay. Now, next question. So hope you understand कि this is the fin. Then you will ask me one thing, कि sir, why we are increasing area? Directly we switch on the fan. We switch on the fan, body will cool. Of course, that is a very good choice. But remember one thing, whenever you want to switch on the fan require electricity. So everywhere how you will provide electricity? Fan will create like your sound and other designing parameter. You have to purchase the fan, you have to maintain the fan, you have to do the wiring. So there are many other issues are there. So there are many sectors are there where electricities are not available. So how you will increase the fan? So please listen carefully. Fin is used when H is low. H is low means imagine it's a hot summer. Imagine it's a hot summer. In hot summer, what happens? The wind is not flowing with the high velocity. So the wind is not moving with the high velocity. That's why you are uncomfortable. So H is low. Whenever, remember one thing, whenever the H is low, if the H value is low, then only you need to increase area. Okay. If the H value already high, if outside is a cool, then why you will use required fan? You don't require AC or fan if outside there is already cold. So please listen carefully. There is a need of fins only when H is low. So that will be our next question. So as you can see here, the effectiveness of fin will be maximum in an environment. Once again, the effectiveness of the fin will be maximum in an environment. Just now I told you ki H should be low. If the H is low, then only you need to use fin. If H is low, then only you need to fin. So free convection, yes. In free convection, H already low. Please, those who don't know what is free convection, forced convection, just go through the notes or just read this, you will understand. So in the free convection, H is less. Okay. Then you have forced convection, then radiation, then convection and radiation. So what is the answer? The answer is free convection. Okay. Just a second. Wait a second. Majority of the students are asking the same question ki like how many questions we can expect and all that. Please try to understand, this is the first time there is an extra syllabus added for electrical engineer. Okay, so there is a thermodynamic, power plant and heat transfer. So exactly it is very difficult to say, right, because the paper is very compact, there are many subjects are involved. So that's what, because if I say anything like a 2 or 3 or 5 or 6, immediately the student will consider it as a benchmark because sir told. No. So please listen, as this is the first time these subjects are added, believe me, no one can give you the exact weightage. So that's what weightage concern, it is difficult to predict because I don't have any reference papers so that I can say ki this may be the weightage. If you talk about the mechanical, that is a different thing. But in electrical engineering, I don't think so ki someone will give you the exact weightage. But if you consider the thermal, power plant and heat transfer, if you compare the other branches, thermodynamics will come to the higher weightage in mechanical, then power plant, then lastly heat transfer. So heat transfer weightages are lesser compared to thermodynamics and power plant. This is expected in other branch like mechanical. But here, so directly it's very difficult. Please listen carefully, it's very difficult. But as I can say, thermal, power plant, these are the two major subjects which is required in all the power plants. Okay, so you cannot expect the heat transfer weightage more than the thermal and power plant. But once again, this is the first year, so we don't know the exact weightage. But I am sure from my experience, ki don't prepare so much deep like a mechanical papers. Just have a basic idea ki what is radiation, what is convection, what is convection. Whatever I am covering the question, that is related to topics. Okay, and suppose if there is any particular things are required, that I will cover in the next videos. So this is the score booster series where we need to solve the multiple questions. And remember, this is not the videos where I need to discuss the topics. Here our purpose is to quickly revision on the subject. Okay, now next one. So please listen, the effectiveness of the fin will be maximum in an environment where H is less. And H is less means there should not be fan, there should not be AC. In natural environment, we need to use fins. If there is an artificial environment like fan or AC, we don't need fins. Okay, so A is the right answer. Now the next one. Next one. The question is, in an equation of Fourier law of heat conduction, heat flow through a body per unit time. So what I am trying to say, Fourier law of heat conduction, Newton's law of cooling, Stephen-Boltzmann law. These three, first you prepare. You don't look at the syllabus. First, Fourier law of heat conduction, Newton's law of cooling and Stephen-Boltzmann law. These three you prepare first. Then you think about other issues. Okay. So what is this? In an equation of Fourier law, heat conduction, the heat flow through per unit time is Q is equal to minus K dt by dx. The negative sign in the K equation is to take care of. Say, this is your body. heat always flow from higher temperature to lower temperature. So here T1 is greater than T2. T1 is greater than T2. Now always remember, we have basic practice. We will measure the thickness always in positive. So we will say this is x is equal to 0, this is x is equal to plus L. So what is change in temperature by change in thickness? So this will be T2 minus T1. This will be L minus 0. So this is negative and this is positive. This is negative and positive. So delta T by delta X, this is negative. What does it mean? It means that X is increasing, temperature is decreasing. As X is increasing, temperature is decreasing. Okay. So X is increasing, temperature is decreasing. So remember, if you use this equation, Q is equal to Ka delta T by dx or dt by dx. If you write like this, ultimately what is our aim? Our aim is to get the positive number. We don't want negative. We don't want negative. That negative has a different mindset. Negative heat transfer don't justify anything. So please listen. In a glass there is a water. In a glass there is a water. So either there is water or there is no water. In a glass there is a water. So either there is a water or there is no water. So similarly, either there is a heat flow or there is no heat flow. Either there is heat flow or there is no heat flow, but there is no concept of negative heat flow. So that's what I want to make it. This is positive. So thermal conductivity is positive. This area is positive. dt by dx is negative. Why? Because as x is increasing, temperature is decreasing. So due to this reason, to make it positive, we added the minus sign. We added the minus sign. Okay, we added the minus sign. Minus Ka dt by dx. So what is the options? Decreasing temperature along with the direction of increasing thickness? Yes, this is absolutely correct. This dt by dx is negative. To make it positive, we choose this minus sign. So please listen, in the Fourier law there is no minus sign. Minus sign we added. Minus sign we added so that the heat transfer value should be positive. That is the answer. So please listen carefully. You whatever your subjects are there, like power system, controls and other things are there, compared to that the heat transfer level of difficulty you need to assume very superficial. Superficial means what will be the first level of difficulty in heat transfer. Let us say there are 10 level of difficulty, 1, 2, 3, 4 and 10th. So in your case you need to assume that it's a very superficial level of difficulties. So please listen carefully. Whatever the books are available, like objective questions in the market, any market, objective questions, and whatever the simple questions are there on the heat transfer, you can use that. Definitely you will say, sir, should I follow the GATE paper? No, GATE not recommended. Should I follow the engineering services prelims? Yes, in engineering prelims, whatever the questions are very superficial. So what you need to do, in engineering services, mechanical engineering, there is a papers, previous ESE papers. So in that previous ESE paper, whatever the easiest question without any much data, that level of difficulty you can expect. Okay, that you can expect, but not more than that. Okay, so don't expect the higher level of difficulty. Next one. Next question. A wall of thickness 0.6 meter, a wall of thickness 0.6 meter has a normal area 1.5 meter square, is made up of material of thermal conductivity 0.4 watt per meter Kelvin. The temperature of the two sides. So let us say this is the wall. Let us say this is the wall. So area is 1.5 meter square. Thermal conductivity 0.4 watt per meter Kelvin. The temperature on the two sides. Okay. So this is 800 degrees Celsius and this one is 100 degrees Celsius. What is the thermal resistance of the wall? L by Ka. So L by Ka. So L by Ka is 0.6 by K. Thermal conductivity 0.4, area 1.5. Now remember one thing, some student will use this formula, Q is equal to delta T by L by Ka. Okay, or you can write K delta T by Ka delta T by L. Some people will use, but he did not ask heat transfer. No, you need to read the question. Thermal resistance. He did not ask the heat transfer, he asked thermal resistance. So due to that thermal resistance, if you solve this 3 by 2, 1.5, so this answer is 1. Answer is 1. So you need to go for option first. So first is a right. Remember, he did not ask the heat transfer. He did not ask the heat transfer, he asked the resistance. That is the case. Next. Okay, heat is conducted through, so there is a wall. So there is a 10 centimeter wall, or you can write 0.1 meter. Heat at the rate of, so at the rate of per unit area, so Q by A is equal to 30. When the temperature difference across the wall, so this delta T is 10 degrees Celsius. What is thermal conductivity? So you can write like this, Q by A is equal to K delta T by L. Okay. So you can write this Fourier law if you arrange this. So this one already we have 30. Thermal conductivity we need to find. This is 10 by 0.1. So this K is equal to, okay. So what you will do, this is simple. So please listen, some student will think, sir, where is a minus? Don't take about that minus, because that is adjacent in the delta T. So this Q by A, K, delta T by L. So here, please listen carefully. Thermal conductivity is given in watt per meter, watt per meter Kelvin. So it is given in watt per meter Kelvin. So this should be in meter. So don't put 10 centimeter. No, unit will not balance. Unit will not balance. Okay. So please listen carefully. So if you solve, I think you will get 0.3. Okay. So if you solve, I think you will get 0.3. Okay. Now, so this is the question. Okay. So please listen. Here, don't put the 10 centimeter directly. No, don't put directly 10 centimeter. We need to put 0.1 there. We need to put 0.1 there. Okay. Next. Next. This is important. This is very common question in most of the examination. A composite wall consists of two layers of different material. So let us say there is a two material. So this is K1, this is K2. So please listen, it has an equal thickness. This is L, this is L. If we make it single, so there are two walls K1, K2, LL. If you combine, then what will happen? This become 2L. This become 2L. So for equal thickness of the two layers, the equivalent thermal conductivity, when you add this K1, K2, when you combine, L plus L become 2L. But this rule is not applicable. It not be K1 plus K2, because it's a material property. It's a material property. Just by joining the two material, immediately K1 plus K2 will not come. So what you need to do, the resistance of the one and resistance of the two should be is equal to R equivalent. Whatever the one offer resistance plus two offer resistance, this body will offer that much resistance. So this is L by K1A plus L by K2A is equal to 2L by K equivalent A. Area L get cancel out. So 1 by K1, 1 by K2, 2 by K equivalent. So solve this. So 2 K1, K2 upon K1 plus K2. Okay, so if you solve this, you will get 2 K1, K2 upon K1 plus K2. This is very standard result. Okay, so this is from GATE, ESE, public sector, any examination you find. This question is very popular, very popular. So what he's saying that if the material is 1, 2, if you add, what will be the K? So the K will not follow this rule, that R1 plus K1 plus K2 will not follow. So whatever the resistance offered by 1 plus resistance offered by 2 should be is equal to this resistance. Okay, so that's why C is the right answer. C is the right answer. So make sure this question you need to take care. This is very common in any, like if you see the TS GENCO mechanical paper also, you will find these questions. Okay. Next one. Next one. So please try to understand. Okay. This is very important. Next one. A cube at high temperature is immersed in a constant temperature bath. So there is a cube. There is a cube. It loses from its top. Let us write this is H1. It loses heat from its top, then sides. Okay. Loses from the top, bottom, that is H2, and this is H3, sides. Respectively, the average heat transfer coefficient for this cube. So what is the average heat transfer coefficient for this tube? This is the question. So there is a heat loss from top, bottom and sides. So remember, please listen carefully, we need to calculate average. Okay, we need to calculate average. First of all, please listen, if you see the Q total, so this will be Q top plus Q bottom plus Q sides. Okay, so this will be H into 6 sides, 6 into area of each side, delta T, top is only 1, HA delta T, plus bottom is only 1, HA delta T, plus how many sides are there? H3, 4 sides. So where area is, area means one side. So 6 area, 1, 1, 1. So delta T get cancel out. So what you will get? 6 H bar, this is average, is equal to H1 plus H2 plus 4 H3. So what is H bar then? H1 plus H2 plus 4 H3 by 6. So everyone listen carefully. This is the cube. This cube is kept in environment. There is a top side, there is a heat loss. So top is only 1. Bottom side, bottom also 1. But how many sides are there? 4 sides. Total sides are 6. So top, bottom and sides. So the Q total is equal to top, bottom plus sides. Total, when you take the total, so it should be 6 sides and average H. One is top, 1 is bottom and 4 are sides. So if you do this, you will get this answer. Okay. So H1 plus H2 plus 4H3 by 6. So you can see here A, B, C not there. So D is none of this. So the correct option is not there. So A, B, C. What is the answer? D, none of this. So H1 plus H2 plus H3. Okay, 4H by 3. So don't get tempted, array sir, H1, A should be there. No, sometimes none of this also the right answer, right? So if you prove it here, H1 plus H2 plus 4H3 by 6 should be the right answer. Clear? Okay. Next one. This is a very this is important question. Again, it is important question. Multiple, see, what I did, I just went like with the various papers, GENCO, Karnataka Public Service Commission, AP GENCO, Maharashtra GENCO. I collected the papers. Okay, I collected the papers and I just figured it out. What are the very like high frequency question? What are the questions which is repeated in most of the service commissions? Okay, so that question I am keeping here. That's it. Okay, so whatever the question I am discussing, this is the very high frequency in most of the examination. Next one, listen. It is desired to increase the heat dissipation rate over the surface of electronics device of spherical shape. So spherical shape, radius is 5 mm, exposed to convection 10 watt per meter square Kelvin by encasing in a spherical sheet of conductivity. So please listen, this is a spherical body. This is the spherical body, and there we enclose in a sheets. Okay. So this sheet, this thermal conductivity of this insulation is 0.04 watt per meter Kelvin. 0.04 watt per meter Kelvin. For maximum heat flow, what is the diameter of that? So first of all, remember the critical thickness concept is a different thing. Okay, it's a different thing. So what we will calculate, first we will calculate RC. What is RC? Critical radius. Critical radius. So that critical radius for sphere is 2K insulation by H outside. Okay. So RC is equal to critical radius. So critical radius is equal to 2K insulation by H outside. So this will be 2 into 0.04 by H. What is H? 10. So this RC will be 8 mm. Okay. So please listen carefully. Maximum heat flow take place. Maximum heat flow take place when this radius means this outside radius of the sheet, this R should be is equal to RC. When what is critical radius? Critical radius is 8 mm. So when we insulate by 8 mm, we will get the maximum heat transfer. So at 8 mm we will get the maximum heat transfer. So we need to insulate 8 mm. So in the excitement, don't choose the 8 mm. Why? Because if you read the question, he says diameter. So it happens many times in the excitement we will say 8, but we need diameter. So diameter is twice of RC. So that will be 16 mm. So 16 mm should be the right answer. 16 mm should be the right answer. So that is your answer. See, make sure he did not say for cylinder. He said it's a sphere. If it is cylinder, then the formula is only K by H. So K by H is a critical radius for cylinder. But he said for sphere, and for sphere it is 2K by H. For sphere it is 2K by H. This is for sphere. And at the end what he asked about the diameter. That's what we multiply by 2. And we got this 16 mm. Clear? So please listen, there are infinite number of questions are there, but you can't solve all. If it is cylinder, what will happen? He did not ask thickness. Thickness is different. Okay. Now, next question. So, please listen. We need to match list 1 with the list 2. Black body. Black body means this A. Black body, emissivity does not depend, mirror-like reflection, zero reflectivity. Yes. So, black body don't have any reflectivity because black body absorb everything. So, reflectivity is 0. So, A3. Then grey body. Grey body doesn't mean it appears to be grey. No. In grey body, properties are independent of wavelength. So, grey body, B. Emissivity does not depend on wavelength. So, let's go for 1. Then diffuse body. Diffuse means it is same in all direction. Diffuse means same in all direction. Okay. So, D4. Then remaining specular, mirror-like reflection. So, this is options A3, B1, C mirror-like reflection, D intensity all direction. So, 3, 1, 3, 1, 2, D, 2, 4. So, go for option D. So you need to go for the option D. Why? So why I am taking this question? So that you need to read about black body, grey body, specular body, diffuse body. That is the only aim. So you need to read about these bodies. So whenever you are studying about the radiation, make sure these bodies, black body, opaque body, grey body, this you need to study. That is more important. Okay. So intensity is same in all direction, right? So that is the case. So please listen. I solve around 15-16 questions, I think, in all the topics: convection, conduction, radiation, and all that. I just want to give you the glimpse of the heat transfer. Of course, this is not the complete thing, and please try to understand. No one will give you the exact weightage. No, because at the end of the day, I am not going to write the exam. If something goes wrong, you will be suffer, not me. So my prediction may be wrong. So that's what this prediction and probability, you should not play the game. You should play the game with the subject. If you prepare the subject, if you have the fundamental clarity, then your chances of clearing the examination is very high. So that's what, from my subject, I am unable to give you the exact weightage, but I strongly believe that you don't find many questions, because priority will goes to your core subjects, then thermal subjects, then power plant subjects. Then at the end, some questions will be there, and that sub questions will be basic. So what you need to prepare: Fourier law of heat conduction, Newton's law of cooling, Stephen-Boltzmann law. These three laws you need to prepare. You need to prepare all types of body, black body, grey body, and some basic definition. Don't solve any much numerical which require calculator or something. Very superficially questions you need to prepare, that you will get in ESC papers, engineering services, mechanical, previous paper. That's also some questions are tough. Don't panic about that. You just need to understand what is fins, what is Newton's law of cooling, what is Fourier law, what is black body. Only definitions you require. You don't require much in depth of that. Okay. So if you already studied in 11th and 12th, it's very good. Otherwise, don't study too much. Just read in a brief. Okay. So this is our score booster series. This is our score booster series conducted for 1 hour. So it's already 7 o'clock. So my time is over. So I wish you all the best. I wish you all the best for your upcoming exam. I want you should have a great life. So that's it from my side. I am signing off. Thank you.